Hello, welcome to my YouTube channel Process Simulation. Today we're gonna discuss about a very important topic in process engineering related to the gas field, that is process gas processing. So we will see what's our agenda today, how which topic we will gonna cover today. So our agenda will have four things. One thing is gas dehydration and conditioning. In this we will usually talk about the hydrates, what are the hydrates, how they are posed, how they we can prevent them, and what are the most common method available in the industry for dehydration and conditioning. Conditioning means heavy hydrocarbon removal. And the third topic is the gas sweetening. So we will discuss what is S2S. We will discuss how the different processes are there in the market, license versus unlicensed product. And then in third we will see the most trending thing of the topic is LNG and NGL. What are the benefits of having NGL and what is LNG? Let's first take a deep dive into some bases. So first thing is that what is why do we want to process the gas? And so some basic reasons are we want to process the gas to meet the customer or end user requirement. And that the end user requirement mostly are the heating values, are the water contents, are the hydrocarbon dew point, and the composition. Composition means impurities they have the value. For example, mercury, CO2, nitrogen, H2S. All these are the impurities in gas which definitely affect the heating value or can corrode the pipe or something like that. Or you can say that these things are, and water also can give uh, in the presence of water, CO2 and H2S can, and the corrosion rate can be increased. So everything we have to know. Water content, there are some specific these are customer to customer change in some country having different pack. So all these things are here. And the most thing is that we want to minimize because we want to eliminate, but definitely we cannot eliminate. But we minimize the handling problem because gas can only handle through the pipelines. There is no kind of a container that you, or you can say by truck or by ship you cannot transport the gas. So definitely water is removed to prevent the corrosion. Hydrocarbon liquid remove is removed to avoid slugging, because if you have the slug in pipe, definitely that the end facility you have to put a big slug catcher, or that will have too much liquids, high velocities, two-phase velocities, not good for piping. And then the high velocities, high momentum that cause any damage to the piping. And third is the hydrate formation in the gas pipeline, because hydrate is not just only the presence of the water. We will do and discuss in detail. So hydrate formation in gas pipeline can lead to the blockages, complete blockage of the pipeline. We will see how this works. Okay, the important topic: what is hydrate? Hydrate is not a chemical thing; it's a physical thing. That's a combination of water with the carbon molecules from C1 to C4 hydrocarbon molecules, and it also has H2S and CO2 molecules. Produce a solid which look like the ice like appearance, but possess a different structure than ice structure. If you talk about the structure, ice having some different structure. It look like ice, but it's not the ice. If you can see on the left, there's a carbon, CO4, CH4, methane, and on the right you can see if water molecule Kh become, and this become a kind of a solid thing looking like a ice. 4 kgs type SL methane hydrate. This is what the I'm talking about the structures. So what is hydrate? We will continue this. The other three conditions that very affect the hydrate, that is the composition, what how much is C, how much is hydrocarbon, how much is water, what's your operating temperature, and what's your operating pressure. And if you can see on the right, these are the hydrates. They block the pipeline, and it's cause a big thing, big overhead jobs has to be done to take this out, because and you cannot push this fluid out. It's just like a rock, like solid. And they are the softwares in the world. They are in two steps. I will tell you how in this hydride formation we can predict it. What we do to reduce the things is that first we dehydrate the gas. Dehydrate means we remove the water content. So first thing is that if there is no water content or there is very less water content, there will be a very low probability of getting the hydrate. Or we keep the gas at a higher temperature. So high temperatures tends to avoid the hydrate formations. And third is with the use of the chemical. We use the chemicals such as methanol and MEG to shift the curve. I will tell you what I mean by shift the curve. So, so this is the curve. So if you go to any process simulation software, you put your gas composition and then go to the properties, and then you can easily get this hydrate curve. And just put the properties, and you can go and from where do you get the uh, phase envelope? It's from the same. You can get the hydrate curve. Whenever you see the hydrate curve, so the left side is what they call the hydrate formation zone, and right side is called the no hydrate zone, the hydrate free zone. It's look like a similar to phase envelope that's having the pressure on the y-axis, and x-axis have the temperature. So your operating point means pressure and temperature should lie in hydrate free zone regardless of the water composition to make sure there is no hydrate formation. It's a very typical curve, you can see that. And normally the pressures are 100, and it's just a composition. I'm not talking about which composition. It's 1000 psi if the is the operating pressure. So if you have to have hydrate free zone, your operating temperature should be more than 65. You can see it here. If your 100 is your pressure, then you can have that 65. If it is less than 65, you are in the hydrate zone. So that's why what I talked about, that heat retention, that we can increase the temperature. Okay, when we talk about the chemical injection, what happens? There are softwares. I'm not talking in this discussion is not about the softwares and how to predict it. That's we'll have a separate session for that. So if I put any methanol, some specific composition, I can shift this curve towards left. So left means so might be after the injection, my curve will look like this. So same at 100,000 psi. Now my hydrate phase will start somewhere between 55. So I'm coming from 65 to 52 with the help of the chemical injection. This is called what happens when you put the chemical, you shift the hydrate curve towards left. Okay, so these are the things we will move forward. This is the same talking about if you go to high unisim. This is how you get the hydrate curve with the same. This is point curve. And second thing is a hydrate curve. So you can see that if your operating pressure is over 100 bar, you have to make sure that you have to be more than 25. Otherwise, your hydrate will be there. Since we are in the basics, so this topic is now S2S gas. What is S2S gas? S2S gas is colorless, is toxic, is flammable. Its flammability limits are somewhere from 4.3 to 46 LEL, UEL, and LEL. Correct me if I'm wrong in the comments. I'm not good at remembering the exact numbers. It's highly corrosive, and that's why we have to remove it. And it's react with carbon steel surface. It can cause the pitting corrosion, which is more than the other corrosion, because pitting corrosion creates the hole. So based on different company standards, if the gas is having less than 4 ppm, we call it sweet gas, and if it's more than 4 to 5 ppm, we're calling it sour. Some other standard you will go call it 50, some call 100, and this is for the health purpose. And for the design purpose, if you're designing the equipment, you mostly go with the 50 and 100. So what is writing here is less than 49 or 58 is sweet gas, and when it is more, it will call the sour gas. So let's move towards our main topic. Since we have now the idea of that gas dehydration, what's gas dehydration, and we know why we need to process the gas, and we know the stress. So now we have the all basics to go into the gas dehydration and the other topics. So the gas dehydration is a topic called what the purpose is that we have to remove the water from the natural gases or NGLs. And there are many ways of doing it. They have the absorption method, they have the absorption and adsorption both. This mean that you have in the liquid or solid desiccants. Then you have a refrigeration system. Then you have a membrane. Then you can use a distillation. You can use the gas stripping. There are many ways to remove it. The most common is using the glycol, which is come under the first, that is absorption by liquid desiccant. And the most common, and because but that problem with the liquid desiccant and absorption is that they cannot have the bulk removal. They will stick up to 5 to 7 lb of gas, lb of water till in mmscf of gas. If you want a deep removal in ppms, you have to go towards the absorption by solid desiccant or membrane, or through some refrigeration system where they will take the gas to a very low temperature at which the whole water content in gas will convert into liquid, and then they will separate it. This is a common is the glycol absorption that I told you, and there are many glycol MEG, DEG are in the market. This is a very typical scheme. We are not going into deep in this scheme. Is similar like the amine sweetening. We have the first contactor, and then the same your glycol is regenerated. So this is contactor will be at high pressure, low temperature, and if you want to desorb, definitely you have to lower the pressure. This operates somewhere near atmospheric, and your temperature is high because of the revolve. So these are the molecular sievings. We have molecular sieve with one or two or three bed. One is on the absorption, and the other two are on the regeneration in conditions of hot gas comes. And then there's some cooling process. This is you kind of a batch things, and it can give you a very good value up to the 2 ppm that is uh, required for the gases that needs to be treated in NGL or for the LNG applications. So these are the different kind of solid absorbents: silica gel, ammonia, and molecular sieve. And some the best part of it is that this kind of solid bed that does not only remove the water, that can also remove the sweating. So if you have the both application, you can go to the other licensor and they can give you the solution that will be cheaper, because in the one unit you will be having your sweetening gas, it means removal of S2S, and as well as dehydration, that means the removal of water content also. So these are the different dew point value that you can get from the different time of or different type of the absorptions or things. But the more you go, the more less is the dew point values, such as -100. It will be very expensive. This is kind of a membrane system where you put a high pressure gas into the membrane, and what happens is that only the hydrocarbon gas sweep the membrane and become low, and only water contents will come down from the membrane, and they size the membrane in such a way, and and then you can recover the sweep gas that will have some hydrocarbon. You will have some hydrocarbon losses, and but you will get a gas stream that is full of water and which having a lower pressure. So let's move to the second topic, that is gas conditioning, or we call it hydrocarbon dew point control. Yeah, as I told you that we don't want to have the C6 plus, because when you for example you start at 1000 psi, your pipeline and your destination pressure is 400. So when you reach 400, you will have the liquid, and that liquid in the pipeline at the lower elevation will have some pockets, and that will cause a pressure drop. That is was not assume if you get a full gas stream, and definitely that will be the causing the slug, and you need to have a very big slug catcher downstream. So and slug controls are very difficult to handle. For that purpose, there are some method. That is, first is the use of the external refrigeration system, in which propane, or you can say freon type refrigeration system is close to. We will have some other video for the refrigeration. I have make one refrigeration video where you can see at the top for the simulation how that in Hydrates. So in that system, what we do, we cool the gas, and then when cool the gas and the liquid states separates, and based on that separation, we put a separator and we take out the all liquid and the gas is sent to the customer. Similarly, then there is a called JTFX. JTFX is very famous. What happens is that you reduce the pressure by your own from, for example, from 90 bar to 75 bar. Your temperature will come down, and similarly, you can have a cold separator that can move the liquid. But in this, you are losing too much energy. So again, if your targeted temperature at the customer end is 90 bar, you have to add a compressor. And third is a turbo expander and a recompressor. This is one of the latest technique that is used. So in this, some amount of pressure is lost, but it is regained in the expander session. So if you see, the gas will come at 15 degrees C and 90 bar. It will have some kind of turbo expander. It will the home pressure is reduced 25 bar, 0 degrees C low test temperature, and same gas it will go to the compressor from 75 to 85, and that will be based on the same rod, because the rod which is using for the expander, the same will be used for the compressor. So this is the pattern technology that is used. So in this, as compared to the GT valve, it having the higher recovery, higher hydrocarbon liquid hydrocarbon recovery, which with less in the gas system. So the system that we're going to discuss is gas sweetening. So gas sweetening, similarly, we have very same thing like the dehydration, absorption method, some adsorption method, and some membrane. So we have generic amine, MDA, DEA, in equal solution with 40% of weighted average to 6%. Every generic amine have different things. You can go to the GPS in someone table that let you know that how much you can put the MDA in the water. I will make one detailed video just for this generic amine things. And then we have a pattern technology for called sulfonol or sulforex. These are the patterns. I think one is by UOP and one is by some other vendor, and and they give the guarantees for all those things. And they have the molecular sieve, same thing that we discussed. You degenerate the sieve in the batch process, and for that thing, you have to make sure that you have some kind of a hydrocarbon recovery, because liquid hydrocarbon causes damage to the sieve. And then third is a membrane, which is most common and very easy to put, having no moving part, compact, and treat a lot of high volume of the gas with relatively less pressure drops. And the system is, but the problem is membrane is that you will have the higher hydrocarbon losses. It will go towards your with your sweep gas, and that it will have in the S2X or CO2. Some hydrocarbon losses are there. So in membrane also there are many system called single stage or multi stage. Similarly, we will have some videos. If you want to go through, you can go to the UOP website. You will come to know the single stage, I think, and double stage. Single stage is also given by Lumberjell also. They have a one company called Cameron that give this membrane. So this is typical gas sorting units, generic amine. Same like absorption and stripping. Absorption happens at high pressure, low temperature, and stripping happens at high temperature. That is achieved through the reboiler and lower pressures near atmospheric. So uh, what happens? Sulfonal, as I talked about, they are mostly the mixture of different generic hydrocarbon physicals. So this main thing in the pattern is the solvent. They put some kind of a piperazine. They have different things, and that use and that what happened definitely if generic amine is using, for example, 500 GPM to get to treat gas, maybe this license will have a lower flow rate. Lower flow rate means lower equipment size. But thing is that and the solvent itself is expensive, and generic amine is readily available. So there are some cons and pros and cons for everything. Hello. Hello. So moving to the next thing, that is called membrane. Same like as I told you that we have uh, sorry, not membrane. We have bed system also. Sour gas come and then it goes becomes sweet, and and you have one working and one is on regeneration. This is the same thing. Some problem with the slides. It's not moving forward. Okay, so we'll be wrapping up the things as this last topic, that's NGL, NLG, and LPG. So by the name LPG is called liquefied petroleum gas, and then we have NGL, natural gas liquids, and the third that is very famous nowadays is called liquefied natural gas. First is petroleum gas, this natural gas. So this is the top, some C1 to C7. What are the molecular weights, and what is the temperature at which it will become liquid? So LPG mostly C3 and C4. So C3 and C4 is minus 12 and minus 42. So if you want to at the normal atmospheric pressure, you want them in liquid phase, you need to reduce the temperature to minus 12 or minus 42. Impossible, huh? Therefore, definitely, that's why these all things are operated at very high pressure, because when you go to the system curve, or you can say the phase envelope, you can see it. So when the weight is liquid, weight is gas. So if you go to high pressure, you will get something there at normal ambient temperatures, where you have, for example, that's NGL. Is dependent on the composition also, but if your flowing temperature is 32 bar, and then somewhere near atmospheric ambient temperature, you will have the NGL in liquid state. So as I told you, from ethane, propane, butane, pentane, these all are called LNG, and specifically propane and butane. 100% propane also and 100% butane, both are called LPG, and these are three common mixture. One is called 100% propane, 100% butane, and then they have a 50-50, 70-30. So if we talk about the LPG, we will design everything based on 100% propane. So 100% propane is having the high pressure and all those things. And then we have the non-hydrocarbon water oxygen. So if I take a well, uh, natural gas well stream, you will find these things. And methane, if it is converted into liquid, this is called LNG, having some traces of C2 plus. So you can get this. This is all LNG. And this is LPG. Yes, that's all for today. And let me know in the comments what other topic do you need me to cover. Thank you.